Okay, so we're going to talk about Chapter 8, Pure Year 12, which is called the Binomial Expansion. And this chapter is split up into a few parts, but really there's only sort of one main idea, which is the binomial expansion and using it. And you may have seen this a little bit before, perhaps, in something called Pascal's triangle, at Further Maths GCSE, or perhaps somewhere else. We're going to be talking about using factorial notation, which is part of this. Okay, factorial notation has something to do with where we can get these numbers from, and it's shown as an exclamation mark on your calculator. And then finally, it's answering more questions on the binomial expansion. And part 4 is some different variations of questions, such as using them to estimate answers. So in the first part, we're going to just talk about Pascal's triangle and some of the intuition behind where this comes from. So if I ask you to expand these brackets, a bracket to the power of 0, a bracket to the power of 1 is pretty much the same as not having the brackets, isn't it? Wouldn't you get an A and a B? What about this one here, A plus B squared? You would have seen this one a lot. Cubed, you would have probably handled this before as writing it out as squared and then multiplied by another one. And it would involve quite a lot of cleaning up and simplifying, and so on. By this point here, though, really, it's becoming quite tedious, the process of expanding out brackets, for example. It'd be nice if there were a quick way to get these numbers here. And in fact, there is, and that's what this chapter lets you do. So what do you notice about the coefficients, the numbers in front? Well, hopefully you can see that they sort of form like a pyramid, okay, with these numbers here. And this pyramid is getting wider and has all sorts of patterns. So some of the patterns you might notice is that we have ones always as our first term and our last term. You might also notice the symmetry going on here. What about adding as well? 1 plus 2 for the 3, 1 plus 3 for the 4, 3 plus 3 for the 6 as well. Okay, and the powers as well. There seems to be something going on with the powers. You seem to be starting with all of the power on the A, which goes down, and then it's gone. And all of the B, no power, then it's there, to the power of 1, then squared and cubed. There are all kinds of things that you can notice, and all of these properties sort of help us if we wanted to expand those brackets quickly. So these are the numbers, and they form something called Pascal's triangle. Okay, so Pascal sort of discovered this pattern here, and we call it Pascal's triangle. Okay, and we've gone a little bit further. We could keep going if we wanted to add another part on. 1 plus 5 is 6, 5 plus 10 is 15, 10 plus 10 is 20, 10 plus, can you spot the mistake? That one there should be a 5. So 10 plus 5 is 15, 5 plus, well, actually, I know it's symmetrical, so I can just copy that one there. What does this mean? Well, it means if I had a bracket to the power of 0, it would look a little bit like this. It would have one term, and that term would be 1. If I had brackets to the power of 1, well, if there are two pieces, it's called the binomial expansion. I would have two pieces, and they would each have a 1, and so on, and so on, and so on. We could keep going. Do you notice another pattern? How perhaps this one here is linked each time? That will be important for later. So this would be a bracket to the power of 6. And as we can see here, this tells us, you know, the second number tells us which row we're looking at. So let's do an example. Now, I've got 2 plus 3x to the power of 4. So we don't want to be here all day expanding this out, writing it as loads and loads and loads of brackets. We'll be there a very long time. We've got these numbers. Think about where these numbers came from. And at this stage, we can just, let's put that over there, we can just get these numbers for ourselves by remembering the pattern. But later we'll look at how our calculator can give us these numbers. What else did we talk about? We talked about at the start, all of the power falls on one part, none of the power falls on the other, and this pattern changes. So all of the power is on the 2, and then it fades away. There is, if you prefer to think of it this way, there is a 2 to the power of 0 sort of hiding there, but 2 to the power of 0 is 1, so we don't need that. That's the first part. What's the second part? The second part is 3 to the x, but don't forget, 3 to the x goes the other way. So you can start by giving all of the power here, and then reducing it. And again, there is a 3 to the x there, but it's to the power of 0, so it's not written. So this is a very, very quick way of expanding this bracket. Cleaning it up, 2 to the power of 4 is 16. 2 to the power of 3 is 8. 8 times 4. Okay. And then also times 3 should give us 96. And there's one x there, so it's 96x. 2 squared, 4 times 6 times 9, 3x squared. Don't forget, 3x squared is the same as 9x squared. So you can see the numbers are going to get quite large. And we have the part without an x, the part with an x, the part with an x squared, an x cubed, and an x to the power of 4. Typically, a question will ask you for the first 3 parts, or sometimes for the first 4 parts. This is the essence of how you complete a binomial expansion question. Let's do another example. So, I'm going to write it out a slightly different way this time. 1, 1, 1, 1, 2, 1, and the third row is when there's a 3. 1, 3, 3, 1. These are the numbers that I need. 1, 3, 3, 1. From before, we looked at how they are separated with addition. What I'm going to do this time is I'm going to write my part A and my part B together. Notice part B, I've underlined the sign as well. And I'm going to write these in everywhere. And last time. Now, typically these questions ask for you to do this in ascending order of x. In other words, you start with none of the power on the x and you work your way up. So that's what I'm going to do. The first part gets all of the power, and the other part gets none of the power. Then this power goes down and this one goes up. So 3, 2, 1, 0, and the other one goes up 0, 1, 2, 3. Do you spot another pattern? These together always add up to the power that you're using. What's left to do now is to clean up. 1 is very easy to raise to a power. 1 cubed is just 1. 1 squared is 1. 1 to the power of 1 is 1. 1 to the power of 0 is 1. Anything to the power of 0 is also 1. So the first part here is just the 1 that remains. It's not 0, okay? It's just 1. Here I have a 3 and I have a minus 2x. So let's do this part first. A 3 and a minus 2x is minus 6x. So it's plus minus 6x. So I'm going to just say it's minus 6x. So 1 minus 6x. Let's do the next part. Minus 2x is all squared. So minus 2x is all squared. This is 4x squared. It's not 2x squared. It's not minus 4x squared. It's a positive 4x squared. Don't forget, there's a 3 over here. So multiply it together. You should get 12x squared. And the last part. The numbers are 1, okay. But here there's minus 2x cubed. So if it's have a minus cubed, it will stay as a minus. So it will be 8x cubed. Okay. And we're done. So if you can follow that sort of pattern there, the systematic way of doing it, you should actually be able to do any question if you follow it methodically like that. Okay, let's try a harder one. So the coefficient of x squared in this expansion is 720. So find the possible values with an S, that's a big clue, of the constant C. So what we're going to do here is we're going to just sort of start off with what we know. What do we know? What we know, Pascal's triangle. 1, 4, 6, 4, 1. Again, we won't be doing this forever. This is just at the start, okay? 10, 10, 5, 1. So we know some numbers here. We kind of know what the pieces are. And we've been given an answer. A coefficient is 720. So let's just work forwards with that and see if the question opens up. So x squared. Well, I'm going to get the first term that has 0 power of x. Then I'm going to have the x term. And then I'm going to have the x squared term. Okay. We won't write it like this forever, but this is just to start off with. I'm actually not going to do any more terms because this is about x squared, and I know x squared will be covered here. So I don't need to go any further. That's not useful. Some of you may have even spotted I could actually just do the 10 term, but I'm going to do the first 3. So what's the first piece that we have? The first piece that we have is 2. And the other piece that we have is minus cx. So these are going to be our things that we put into brackets. So I'm going to put in 2 and minus cx. 2 and minus cx. 2 and minus cx. We normally do it in ascending powers of x. So we said we'll give it none of the power and then 1 of the power and 2. What should the powers add up to? They should always add up to what was here. Remember, you had a 3 because they added up to 3. So here they should add up to 5. So this is going to be 5 and it goes down. Look, they add together to give you 5 each time because that's what's in the question. 2, that one's going to be 3. So let's clean this up a little bit. 2 to the power of 5 is 32. There's not going to be anything there, so that's just 32. 2 to the power of 4 is 16. 16 times 5 is 80. There's also a minus cx. So I'm going to have minus 80, I think we said, cx. Okay. Again, not particularly useful, but good practice at this point because you often have to do the first 3 terms anyway. Okay, 2 cubed. 2 cubed is 8. 8 times 10 is going to be 80. Okay. Minus cx squared. Well, all of that is going to be squared. So I'm going to say that that's going to be c squared x squared. Okay. Now, we haven't really done anything new. We've just taken the information from the question and we're just working with it and seeing what can happen. Now, I haven't used the 720 yet. It said the coefficient of x squared. The coefficient, because c is a constant, the coefficient means all of this part here. And it says that this is equal to 720. So in other words, 80c squared is equal to 720. C squared, possible values. This is making a bit more sense now because c squared, yeah, if we solve, it's a bit like solving a quadratic. We're going to get 2 answers. Divide by 80 on both sides, we'll get 9. So c equals plus or minus 3. Okay. Now, these kind of questions are a bit more difficult, but all you do is you write out everything that you know for the parts concerned, and then you put that information in. Okay. A common next part would be to say like, oh, what's the coefficient of this one here? And maybe we have to put the number back in or something. So have a go, pause the video, try this one here on the screen. Don't forget, please, when you are applying something like this should be K5 X5. So pause the video and have a quick go. Okay, so part A should have been mostly okay. You expanded out and you simplified and you would have got some large numbers. Okay, part B, a little bit more complicated. So let's just talk you through part B. It says, given that the coefficient of x squared, in other words, this part here, so 672k squared is the coefficient of x squared. This is I read is as an equal sign. This is 6 times, well, 6 times what? 6 times the coefficient of x. So if you go to the x, the coefficient is everything that's in front of it. So this is what you want to do, and that's where you'll get your first mark from. Okay? And if we solve this one here, should get k equals 4. If you've got k equals 0 as another solution as well, you can just ignore that one. Okay? The reason why we ignore this one is because if you had 0x, it's not really much of an expansion. It just becomes 2 to the power of 7. So k equals 4 is the number that we're looking for. This is very, very, very common to do. This coefficient of something is, yeah, I would recommend do it very methodically like I've done it here. The coefficient of x squared is 6 times, okay, if you do it this way, you're going to get the answer. Okay, and time for you to practice a little bit.